Hello, everyone. My name is Jesse Drew, and my co-chair today is Professor Andrew Reimark. Welcome, everyone, to the first symposium on the Global Conference of Engineering Education. Today, we are holding the very first symposium as part of the CAE annual meeting program. The subject of today's symposium is Future Perspective of Engineering Education and the Impact of the Pandemic. The first symposium is co-sponsored by the Canadian Academy of Engineering and Western University. Now, I would like to invite Dr. Yi Bucha, the president of Canadian Academy of Engineering, to officially open the conference. I presently serve as the president of the Canadian Academy of Engineering and was also vice principal, administration, and finance at McGill University. Please join me in welcoming Yi.
Well, merci. Thank you, Jesse. So on behalf of the Canadian Academy of Engineering, welcome to the Global Conference on Engineering Education, where we will discuss the challenges and opportunities to the future perspective of engineering education and the impact of the pandemic. This symposium is the first of a series dedicated to discuss issues related to engineering education and how to ensure engineering programs remain relevant in this fast-paced and even changing world. Just to inform you, those of you who may not be familiar with our organization, the Academy is the national institution through which Canada's most distinguished and experienced engineer provide strategic advice on matters of critical importance of Canada. The Academy is an independent, self-governing, and non-profit organization established in 1987 and is one of the three national academies that make up the Council of Canadian Academies. We have over 850 fellows from across Canada, all of whom have made significant contribution to engineering in Canada in the private, public, and academic sectors. Today, we have an exciting agenda with three panel discussion and presentation from 9 world experts to discuss sustainability and engineering education, changes beyond the pandemic, and new student experience. I wish to thank the two co-chairs, Dr. Jesse Zhu and Andrew Rymack, who are both fellows of the Academy. Jesse is a distinguished university professor and the director of Particle Technology Center at Western University. He serves as a director of the board of Canada Academy of Engineering, and he is also the current chair of the CAE's Engineers Education Group. He obtained a bachelor in engineering from Tsinghua University and his PhD from University of British Columbia. After working a couple of years for Shell in Europe, he joined Western University in 1993. He is also fellow of the Royal Society of Engineering and has received the R.S. Jane Memorial Award, the highest award from the Canadian Society for Chemical Engineering. Andrew is currently the special advisor to the President on Industry Partnership, the Green Economy and Sustainability, and Deputy Director of the Fraunhofer Project Center from Composite Research at Western University. Previously, he served as Provost and Vice President Academic and Dean of Engineering at Western University, and as Department Chair and Professor at McMaster University. His research interests include modeling, design, and optimization of material processing systems. He obtained a Bachelor in Engineering from McMaster University and his PhD from Carnegie Mellon University. I would also like to mention and certainly thanks Jesse and Andrew effort for organizing this conference. I hope you will continue the series dedicated to engineering education, and I wish you all the best for that. I would also like to thank all the speakers with us today. You all world-class experts, and your contribution will make this very successful conference. I will now pass the mic to Jesse, who will present more detail about the conference series. Thank you. Merci beaucoup. And
thank you, Yi. And now I'm going to make a very short presentation about the concept and plan of operation for this conference. engineering education, if we do a quick status check, we can realize the current university education system is not much different from those of the 19th century. And then multidisciplinary, internet, AI, industrial need, demand, and others are bring revolutionary changes to the education. Pandemic actually served as a catalyst for fundamental changes. So are we ready? Are the changes too slow? What is coming? What we believe is the opportunities here and change is coming. We have to tack on it. If we review the education system in the past, if we consider a craftsman or carpenter, they are learned piece by piece, individual knowledge, skills oriented, and then you're just repeating the same thing. This is how we learn. But the present method is so-called scientific method. You really have in blocks. You have layer by layer, kindergarten, primary school, and then in this hierarchy education system. But what might be coming, like some younger kids are doing, they're surfing the internet, they go through the way red arrows. And we may consider it chaotic, but that may become a norm. So it could be called personalized learning paths. What are we facing now? So we're facing more diversified and maybe chaotic learning method. The issues we're facing including dynamic changing education in the new education, and then much diversified need, impact of technology, customized, personalized learning, and then a lifelong learning. Education is for the entrance, but also for the seasoned engineers. So this, we need to be facing new education. Are we ready at all levels? And what happens? What can we expect 25 years, 50 years, or 100 years later? And the leadership, as we are educators and leaders of education, we need to worry about leading. We need to think about leading, not just to code. So this is a picture the education group of the case been discussing, and also among our colleagues. And we're really facing a lot of issues here. What happens with pandemic is the challenges and the opportunities. The coronavirus here, but it can be changed as a catalyst for change. So what I have seen in the past year and a half is that, is this kind of situation. Everybody is learning on the internet, but you see much more than you do. There's some benefit, right? And for remote areas, for this. So an exceptional increase in the use of online teaching tool has led to a series of sequential issues, including increased workload, accountability, etc. The use of online tools, though complex and intricate, does bring in some benefit that are worth exploring in the future. So it is based on those. One is probably a little negative, one is more positive. And based on that, we want to bring this conference. So the unprecedented scale of online teaching start to reshape engineering education. For example, online teaching become a significant part of future education and probably even become a norm, and how to take advantage of that. And traditional program structures and curriculum still suit for the ever-evolving world. Are we going to take about change? So our conference is going to address those ones, but not by a single symposium. So what we do is we propose a global conference of engineering education, but we also use a novel approach. So we have multiple symposia organized by different bodies and coordinated by us. So this is one here, the opening symposium by Canadian Academy of Engineering is here. And next month, we have one with ICEE, American Society of Engineering Education, on July the 26th. And there are more coming. And when we all link them together, we have this conference. So we have an online conference, innovative method to bring most people together. So interconnecting, and perhaps over a year or a few months, and we form a conference. We eventually will have an overall program. Today's conference, symposium, have 3 sections. So the first section will be chaired by me, and then the second section by Kenneth Coley, the Dean of Engineering at Western University, and the third one is by Andrew Reimark. Just a bit of webinar. We divide this into panelists, attendees. Panelists can present and interact. Attendees can send questions. So please send your questions in at the bottom part, and the moderators will pick them up and ask for you. Okay? And you may vote for the question to move them up. And this event being recorded will be available on our website later. So now I'm opening the first session. We have two speakers from Far East, Australia. They are very late. So the first speaker is Professor Elizabeth Croft. She's actually Canadian. So Professor Elizabeth Croft is the Dean of Engineering at Monash University in Melbourne, Australia. She is an expert in robotics, advancing the design of intellectual controllers and interaction methods that support human-robot interaction. She has won national and international awards for her research advocacy for women in engineering and educational contributions. She's a fellow of the American Society of Mechanical Engineers, the Institute of Engineers Australia, Engineering Canada, and the Canadian Academy of Engineering. Now we'd like to invite Professor Croft.
Thank you very much, Jesse, for that kind introduction. I'm going to share my screen. As Jesse mentioned, I'm Elizabeth Croft. I'm the Dean of Engineering here at Monash University in Melbourne, Australia. And I will begin by acknowledging the people of the Kulin Nations, on whose land I am currently occupying, and pay my respects to their elders past and present. This acknowledgement is an important custom in Australia. We do it to show respect for the traditional owners of the lands we occupy, their rich culture, their heritage, and their continual relationship with the lands and waters. I do it to recognize the Kulin Nations as the custodians of this land today. Sovereignty of this land was never ceded. This is the Juukan Cave Complex in the Pilbara in Western Australia. In 2018, the Juukan 2 rock shelter was recognized as having potential to radically change our understanding of the earliest human behavior. There is no other site as old as this containing faunal remains in unequivocal association with stone tools. This site contained 46,000 years of continual human occupation, including the site of the oldest evidence of human with stone tools that's older than anywhere in the world. On May 24th, 2020, this site was blasted by Rio Tinto to access iron ore. And it was legal for this site to be blasted. In 2013, Rio Tinto had obtained permission to blast on this site. In 2014, an archaeological dig discovered the site was more than twice as old as previously thought and rich with cultural and sacred objects. As a result of that new information, the traditional owners of the land tried to halt the blast, but Aboriginal Heritage Act of 1972 does not allow for mining consent to be renegotiated on the basis of new information. In 2017, the incoming government made a commitment to change that aspect of the law, but when this site was blasted, those changes had not progressed. So it came to be that on the 24th of May, 2020, an important piece of human history was obliterated. Blasting on this site, it was not inevitable. There were 4 different ways to access that iron ore, and only one of them obliterated the Juukan Caves. As engineers, as engineering educators, we need to take ownership of what happened on the 24th of May, 2020, in this remote corner of Australia in the Pilbara. We need to make a commitment that our students, our alumni, our entire professional engineering industry acts ethically, morally, and sustainably. Already, 2 companies have changed their company policy to permit their staff to halt work if they fear that it will harm Indigenous heritage. Recognizing that the systems and policies and laws in place do not do enough to prevent this type of tragedy, responsibility is now falling to individual staff. Our responsibility as educators is to ensure that every engineer is equipped not only with the knowledge and skills to make efficient and sustainable decisions to better our society, but also to ensure that these decisions are ethical. And these ethical snares exist in every corner of our industry. Who takes responsibility when a robot hurts someone? Image recognition exists that discriminates against people of color, and biotechnology is there that's based on and tested only on the male body. In fact, despite the fact that women have less car accidents than men, they are 17% more likely to die in a crash because the cars they're driving have been designed to keep men safe and not women. And of course, there are ethics involved when we think about carbon capture, and we have to ask ourselves, are we participating in greenwashing? I could go on. No matter what discipline of engineering you specialize in, there are ethical challenges. We need to acknowledge them and equip our students, ourselves, our industry to address them. I will come back to this theme throughout the rest of my talk. When we discuss education, it is critical that we underpin every conversation, every teachable moment with an unwavering commitment to ethics. So there are three key ideas to help our students address global challenges in a post-pandemic world that I want to share with you today. Those are transnational education, student-led clubs and teams, and industry experiences. Monash in Australia has a global footprint with campuses in Italy, India, Indonesia, China, Malaysia, and operations across 4 different campuses in Melbourne. The engineering faculty is active in both teaching and research at 3 locations, the Clayton campus in Melbourne, the Kuala Lumpur campus in Malaysia, and the Suzhou campus in China. We also have research activities in Mumbai. Engineering, as we know, is a practical hands-on discipline. And so previously, while we worked very closely across our campuses, our students were only taught and active at the campus they attended. Those staff would complete secondments across campuses, but we always kept the student cohort separate until COVID-19 came and our education was suddenly moved to online in March 2020, which was the beginning of our first semester last year. As we made our pivot to online education and scrambled for resources to support the extra demands for this mode, we had an epiphany. Once we were 100% online and our students were not permitted to attend campus or even leave their homes, we had an opportunity to give them an online transnational education experience. As our staff converted their programs to online delivery, we brought staff and students from different international campuses together, achieving economies of scale and freeing up staff resources to provide support for students rather than replicating the same education in different places. The outcomes were that students from China, Malaysia, and Australia were sitting side by side in our online classroom, learning together in groups and being taught by staff who were likely from a different country and different culture. As the restrictions eased in Australia this year, we have been able to move students back on campus for labs and tutorials. However, we have not let go of the online experience for lectures and group work. When I walk into our design labs in our new teaching and learning building, I see teams of 3 or 4 students with another group of students who are on Zoom, and they're from a different campus in a different country, but they're all working together to design an N95 mask. The students in Australia are working on the 3D printing of the filter holder, while the students on Zoom are prototyping new mask designs using sewing machines. Some are on campus, some are restricted to their homes. This has been trading back and forth as restrictions have hardened and eased in all the different countries. This was made possible by strong connections and strong relationships between staff on different campuses. I see far greater opportunity for this type of collaboration in the future, across countries, across institutions, where students complete a large part of their learning online in a cohort, but receive specialized support and practical experiences on a campus close to home. During the tightest of our restrictions, when we had absolutely no students on campus at any of our locations, our educators innovated to provide those critical real-life experiences online. These pictures are from our 3rd year process control unit, which always had a very heavy bench component. Our staff set up the online process control lab, which was used by students located around the world, gaining experience that is actually more realistic than our traditional on-the-bench setup. We have many more examples of this on our website, which you can find that QR code in the corner there, including a video of the process controls lab, as well as our other electronics labs that you can find there. The next idea I want to highlight is the importance of student-led clubs and teams in empowering students to practice engineering to solve global challenges even before they graduate. I know that many Canadian and Australian and other countries, their engineering faculties have clubs and teams. Sometimes these activities are for credit with significant amount of academic oversight and direction in order to meet desired academic outcomes. At Monash, we have taken a very different philosophy. We have more clubs and teams than any other engineering faculty in Australia, and our clubs and teams achieve an incredible level of success. Our undergraduate students, entirely self-led and self-organized, regularly take out prizes in international competitions against the best and brightest students from around the top engineering faculties around the world. And if there is a secret to their success, is that we train and empower these students on how to run an inclusive and ethical organization. And then we trust them to get on with the job. To receive faculty resources, they must provide detailed team charters, have ethical hiring practices in management, have detailed succession plans, and an ongoing commitment to training and development, as well as outreach to the next generation. This training is split between leadership development and technical skill development. While we never tell them what to do, we ensure that they have the skills to make good choices and pursue excellence. And it works. This is our Monash Motorsport team, ranked #1 in the world for their combustion engine and #3 for their electric engine. This team made the decision to drop out of the combustion competition to focus on sustainable transportation. Their future is the electric and autonomous competitions. This decision reflects the values of the team members. And for me, that's ethics in action. Next up, we have our Monash Nova Rover team.
Dr. Croft, you have 3 more minutes.
Okay, who have achieved incredible success with their Mars rover. They seamlessly made the transition to the online competition. We also have the Eco Mileage team, a solar decathlon team, who chose to design a woman's refuge as their choice for the design. And then we have the Deep Neuron team, who worked across all sorts of different places to do their work. I will flick through the next slides very quickly. My point is that we have student-led clubs and teams that give the students opportunities to practice what they learn in class. This is where they practice teamwork and friendship. This is where they make decisions on what matters to them. It's an integral part of their learning that happens in these teams and clubs, and that is they learn about ethics and sustainability. Finally, I think these experiences are fantastic, but I think that one thing that Canada really has brought to the table in terms of education is cooperative education. And I have brought this to Australia because Australia has lost its internship culture with the demise of the cadetship programs that they had in the late 90s and 2000s. And there is absolutely a clear need. There's incontrovertible evidence that Australia is performing lower than it should on innovation indexes. Internships or cooperative education, such as the ones that we have in Canada, is such a common feature of education that makes such a difference to innovation. So this is something that we've launched here at Monash. We have launched a program, and I knew it would work because I've seen it work at Waterloo and at UBC and many other places. 100% of employers would hire their students again, 100% will use the program again, 100% recommend the program. This is just an incredible important thing for our students. It's a hard sell here, but I think that it's important that we do this because participating in industry is fundamental to excellent engineering education. It helps students choose specializations that they really enjoy. It provides reliable, low-cost recruitment to employers, a highly skilled surge workforce, and most importantly, It connects employers to the latest in innovation through strengthened university-industry connection. Contributing to the development of the next generation is not just good for business and good corporate social responsibility practice, but it also is the future proofs their talent supply chain. But most importantly in this context, it provides our students with real life context. They are introduced to messy real world problems and even small ethical dilemmas. They need to see this context to understand how large ethical dilemmas can be faced. The world is always changing. When I look at the 17 Sustainability Development Goals identified by the United Nations, the challenges, the opportunities brought by COVID-19, and much more, it is clear that the world needs engineers now more than ever. I tell my students and my staff that engineers save more lives than doctors. Engineers give clean water, prosperous economies, affordable health, sustainable energy. Engineers are the ones with the expertise, the ones on the ground who need to make the hard ethical calls that can mean life or death for our history, our environment, and our people. We need the absolutely very best to join us in engineering because the problems we face have never been greater. And when they come, the best way for us to teach them is to give them deep international and experiential education and experiences across borders, self-directed in the real world, and always underpinned by engineering ethics. Thank you very much.
Now we go to our next speaker. Our next speaker is Mr. Kang, Strategic Expert, UNESCO International Center for Engineering Education, Tsinghua University in China. Mr. Kang graduated from Beijing University Foreign Studies in 1982 and studied science policy at Sussex University in 1991-92 with a master's degree for science and industrialization, and later was Director General for the International Cooperation Bureau of the Chinese Academy of Engineering before his retirement in 2016. And Mr. Kang is now a strategic specialist of International Center for Engineering Education. Now let's welcome Mr. Jie Cheng Kang.
First of all, thank you very much for inviting me to give a short presentation during this international conference on engineering education. Coming with me are two colleagues of mine from the International Center for Engineering Education, Professor Wang Sunyu and Dr. Xu Lihui. Now let me start with my short presentation, the title of which is Innovation in Engineering Education for Sustainable Development. The first one is China's success story in engineering. As is known to all, China is currently in the middle or upper middle stage of industrialization and urbanization. Its pace and level of development in engineering technology and engineering projects, as well as basic infrastructure, is unprecedented in human history. Take a few examples. First one is manned space engineering. Starting from October 2003, China successfully launched its Shenzhou 5 manned spaceship, and 5 years later, China successfully launched its Shenzhou 7 manned space flight, during which the space astronauts achieved spacewalk. And in terms of high-speed railway network, China has developed high-speed railway network with rapid speed. As far as bridge building is concerned, China completes 1,000 high-level, high-quality bridges every year. So you can imagine tremendous amount of raw materials like steel and cement are needed for such mega engineering projects. And this slide shows ultra-high voltage power transmission projects. The ultra-high voltage defined as a voltage of 1,000 kilowatt or higher alternating current, or 800 kilowatt direct current. And China has made a successful story in the construction of ultra-high storage power transmission lines. Now, in the midst of such gigantic urbanization and industrialization wave, unprecedented in human history, China is also facing a combination of challenges in economic, social, resources, environmental, as well as labor and human talents. So that's why China is facing daunting challenges. Name a few. One is social and regional development unbalanced. as is quite well known to you all, China's southeast is very well developed, while the northwest has lagged behind. And China, during more than 40 years of economic development, has consumed tremendous amount of energy and resource. And environmental problem has occurred here and there, so that the environmental carrying capacity has weakened greatly. And off-the-farm migrants seeking for jobs in big cities is a common phenomenon nowadays. Old age is occurring in China's economy. And last but not least, global warming and climate change has posed a huge challenge, not only to the whole world, but to China in particular. All in all, this gives people a summary of one word, that is unsustainability. Not only the Chinese government, but people of all China have recognized this serious problem. So in the midst of such a gigantic urbanization and industrialization, we have to solve the problem of unsustainability. So to address these challenges, China is now saying goodbye to the unsustainable development model and is now embarking on the path of higher quality development driven by technological innovation. The key issue is how education, particularly engineering education and technical training, can foster quality workshop engineers, technologists, technicians, and craftsmen for a high quality economy, so as to raise China's international competence and image. The main challenge for China is to train very high level team, very high level technologists employed by astronauts. China's big company in launching satellites enabled high quality welding that has enabled China to successfully launch a series of satellites. And this is a workshop that I have recently visited that attracts young students to learn technical skills in the workshop place, and which has attracted the attention of quite a number of German companies in China. I want to address that China is now facing a problem in its education system. The two types of education that do not meet. One is general education, which is socially recognized with high social status, and the other is vocational education. The young students enjoying this part of education have been prejudiced against with low status. So the question for China now is, what kind of students do we need? The answer is to train high-end basic research that target origins of research, and we need also engineers in the frontiers of engineering, and high-quality skilled to solve workplace problems, etc., etc. The last one is those engineers that are aware of addressing global challenges. So recently, just last year, the country has convened a national program for the reform of implementation of vocational education. This direct at solving this problem. About 2 months ago, the National Conference on Engineering Education was convened in Beijing, just to leave important messages for fundamental innovation in China's educational system. The last topic of my presentation is on engineering education for Sustainable Development Goals. The 17 Sustainable Development Goals issued by the United Nations has been well known to the whole world, and is gradually won the heart of the whole Chinese population more recently. 11 years ago, UNESCO first report on engineering, and then just more recently in March this year, UNESCO launched its second book on engineering, the title of which is Engineering for Sustainable Development. For a few examples, Chapter 1, Engineering, addresses all 17 Sustainable Development Goals. And a more recent example shows how engineering can help fight the COVID-19 and improve human health. And this is a picture that I have got, that the satellite launched by a Chinese company could be very efficient in guiding and directing on Earth mobile hospitals, which is very, very efficient. In order to link more closely with the whole world, particularly with the developing countries, the ICEE, International Center for Engineering Education, was jointly founded by Chinese Academy of Engineering and Tsinghua University under the auspices of UNESCO. And this center was launched officially in June 2016. And this was the launching ceremony. The Director General Bokova of UNESCO together signed Memorandum of Understanding with the CAE President Zhou Ji. In this report, two words were prioritized or emphasized by UNESCO. One is Africa and the other is gender, so as to address this global inequality in engineering education. And China, especially the Center for Engineering Education, is having an aim and a great task of working with the world community to help Africa to raise its engineering capability, as well as raise the level of young girls in Africa in engineering. So our effort is aimed at raising the engineering capacity building for a better world and a better future. And this is the end of my presentation. Thank you all.
Thank you, Mr. Kang, for sharing your thought about engineering education. And now we come to the panel discussion. We have the two speakers here as panelists, and other members on the board can also ask questions. I'm trying to gather the thought of the essence of your presentation. It seemed to be we're emphasizing on international learning, a combination of vocational and university education. But in general, we're more talking about what kind of future engineers will be training for, okay, and in consideration of sustainable development. So with that, Professor Croft talked about emphasis about online, offline learning, combination of that, and international education. And Mr. Kang mentioned about vocational training and university training. I lived in Europe for a few years. I think countries like the Netherlands and Germany does pretty well in having those two systems together. So I think we all have experience this, but the question that with the change in the global situation, how do we promote international education? I think the sense is that the general sense that we have engineers to be exposed to more new things, education in other countries and education in different systems like vocational and university. So the two of you want to comment on how can we really fast track that to facilitate such learning experience? Do you have any comment?
I'm happy to jump in. I think COVID has actually provided us with that opportunity to have international experiences from our own homes. So, I've spent a year going to conferences and I haven't gone on a plane. Our students have been all around the world in competitions without leaving their homes. And so that has actually provided that opportunity to, meet new people, learn from different cultures. And that's something I think we want to keep and we want to grow is to take advantage of this suddenly, it's clearly not perfect and all of us are zoomed out. I totally get that. But I think we need to have that balance of in person and online, and we can seem to work out time zones and we can work out those other things. So that's the actually kind of the gift of COVID.
Okay, there's a question asked by somebody from the audience, mostly talk about how to measure and certify learning on top of creating meaningful, impactful learning experience. I think he's talking more about evaluation. How do we address that? That question was to Professor Croft. You already answered that. Could you say a little more on that?
Sure, I'd be happy to. So our colleague was asking about how do we, when we have these more deep and rich, but less structured learning experiences, it's often a challenge to assess how well the students have learned. And so the question is, how do we assess, how do we handle this elephant in the room of analyzing or understanding the individual learning? We can look at the group project and we can say they built something, or they developed a women's shelter, or they built a vehicle that can go so far. But how do we measure their individual learning? And so some of the things that I think are important are to ask students to be able to present their work individually as well as at a group. So often we get the students to make individual little videos of their part and to present those. We get them to do poster presentations. We ask for peer assessments because one of the things I think it's really important for students to learn is how to understand and assess each other's work and to give constructive criticism. And it's our job as educators to help learn how we can teach, how our students can learn to teach each other, because actually that's where they are learning the most. So I'm actually a big fan of oral exams. I think, we can expect actually more of our students, and they can handle oral exams just as our PhD students do, maybe a little shorter ones, and but that's good. And I think those are sort of the things that we can think about beyond traditional exams. And right now we're very challenged with traditional exams because invigilation online is not perfect, as we've all discovered. So I think having different kinds of exams is something that we're going to have to look at in the future, and is far more realistic to an engineer's life. Nobody's going to ask me suddenly, can you do this triple integral? Nobody's going to ask me that right now, but they are going to ask me to explain my work.
It is interesting to talk about evaluation method, but the current exam or the past exam are not fair either. They're not necessarily the best thing to have, right? We just have the easiest way to do it, relatively fair, and that's it. So like I have been conducting, if you have smaller classes, you can do oral exam, discussions. When you have bigger exam, when your resources are low, that's become really a problem. Now we're going to online examination is really a problem. They have created all the way to check whether you are there. But if I set up another computer beside my son, I can still answer many of the questions for him. You wouldn't be able to see it. So that is a really real challenge. Probably we'll discuss in the future. Mr. Kang, somebody was asking what's the difference between vocational and general engineering. I think that's mostly university and college education when we talk. Interestingly, our university, Western University, has developed a joint program with a local functional college of engineering with practical experience. I don't remember whether it's 4 or 5 year program, and that is actually to address this issue. So, Mr. Kang, you're talking about China. Yeah. I know China, this can be difficult because their pay and their recognition are quite different. How are you going to do it?
Yeah, Dr. Zhu, can I elaborate just on this question? To answer this question, it has to be clear in mind that career or vocational education is one of the two types of education in China. That's vocational education and then general or degree education. And then engineering programs appear in both types of education. So the central point in my presentation that the innovation in engineering education in China is now occurring with an aim to break the block between degree education and vocational education. That the students of vocational education can, after a few years of practice, go on to degree education. And some years ago, these two types of education do not meet. So now the innovation or revolution in China's education system is to break the block of the two types of education. I'm not sure whether I have answered this question.
Yes, thank you. We want people to be loaded with a bunch of knowledge, sometimes they never use or be outdated very quickly, or we more equip the student with ability to learn, to survive, to excel in their job. That's very important because we emphasize too much on knowledge rather than a full development of the student. So into the pandemic and online learning may be opportunity for at least some of the students to excel, to develop their independent abilities to handle things. Some students may fail, may become more behind, but some will be more advanced. Those students who really want to learn, they can become, really learning a lot of stuff. Any comments from Dr. Croft?
Yeah, you'd think I'd learn by now. So I wanted to answer the question by Eunice Ballum, who was asking about using curriculum specialists thinking through reform and restructuring of our engineering education. And I have to say that actually one of the things I've really enjoyed is we have 5 curriculum specialists in my faculty, as well as education-focused academics, a group of those as well. And I think that has done a huge good in terms of uplifting our curriculum, people who are taking the time to think about new ways of delivering our curriculum. They sure were fantastic when we all had to go online and there were a bunch of specialists who knew how to use all like Panopto and Zoom and Discord and all of these things. That was quite sweet that those people were around, but also having people who are experts in engineering education. I can't stress enough how valuable they are in helping to guide and think about different ways of delivering education. Because as you have rightly recognized, Jesse, the old way is not going to get us any further. We really do need to think of new ways of delivering our education to give the promise of the future for our planet in terms of engineering education. And that's on us to use all the best pedagogy and all the best tools that we can to deliver our education.
Thank you. Thank you. I totally echo your last point. The old way is not going to get us anywhere more. We have to be thinking of new things. That's why we're developing this conference series, and hopefully we can be successful, or at least we can open more questions, at least to make people think. If we can make more people thinking about the future of education, I think we're very successful on that. And now I'd like to thank both Professor Croft and Mr. Kang for joining us and providing valuable contribution, and also consider their time, especially, Dean Croft is already close to midnight in Australia. Okay. Thank you very much for your participation, and are now hand over to the next session and Dr. Kang Coley.